Back, ladies and gentlemen. By this time you should be very tired of this electron configurations. We've done so much already. 1s, 2s, 2p, 3s, 3p, whatever, too much. Noble gas configuration all down. So last step here is orbital notation. You've seen some of this on what you call it, the Hog Hilton. We did some of this already, so it's fairly easy. We're just drawing arrows, okay? We're just drawing arrows here. So electron configuration for nitrogen, for example, 1s2, 2s2, 2p. Nitrogen has how many electrons? 7 electrons. 2p3. Pretty easy, straightforward there. So we draw arrows. Okay. We fill the electrons. Remember, we go in order from lowest energy level to highest energy level. This is written horizontal, so you can't see how the level is portrayed in actual energy level, but just fill up in order from smallest to biggest, following those rules, right? 2 arrows per box. When there's 2 arrows, one must point up, one must point down. You draw the up arrows first, and yeah. So let's apply that. Up, down. Draw it like that. Up, down. 1, 2, 3, 4. And now we have 3 electrons. You've got to put 1 per room, 1 per orbital before you can start pairing them. Okay, same rule, so it should look like that. It is not going to look like, so your last 3 is not going to look like this. 1, 2, 3. So that is wrong. That is wrong. You've got to have 1 in each box before you start pairing them. Alright? Now, noble gas configuration, we practiced that already. Here, not much of a shortcut because it's not a lot. Helium is your gas. And then 2s2, 2p3. Okay, that's that. We practiced that in the last section, so you should have that down. Nickel is 28 electrons. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Right? Just check again to make sure they add up. 4, 10, 12, 18, 20, 28. Perfect. So we basically fill up all the way to 3D. We know that. This is full. Up, down, up, down, up, 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 down, 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 up, down, up, 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 down, down, down. All those are full. Up, down. 4s is full. Now 3D is 8. 8 is not full, so it can hold 10. Remember, D can hold 10. So you go 1, 2, 3, 4, 5. Get into the habit of doing that. Putting all the up arrows first, and then putting the down arrow. 1, 2, 3. There you go. You should have 3 pairs and 2 single ones. All right. And ladies and gentlemen, that is how you do orbital notation. The noble gas. Go back to the rule. Nickel's on row 4. Nickel's on row 4. So we're going to go 4, go argon is the row above. Go to the row above, get the noble gas, argon, and then 4s2, 3d8. And that's the noble gas configuration. Alright, so just extra practice, and you know that this part right here, you really look at it, that is your argon. So we cut that argon part shorter by writing just the symbol argon for the noble gas. Okay. So go ahead and pause the video, go through and do these 2 problems first before you continue playing it. So pause it. And so configuration for ions here. Remember, iron atomic number. Look for the atomic number, which is 26. It's got a +2. What does that mean, huh? Takes us back to previous unit. +2 means it lost 2 electrons, so now we only have 24. Okay? So it lost 2, so now we only have 24. So, oh, that's kind of not so good here. Only oxygen is negative. So only oxygen gained. So oxygen is atomic number 8. It gained 2, so it got 10 electrons. Okay, that's the only one. That's the only one that gained. Everybody else lost because they're all positive. So what you do is you write the configuration: 1s2, 2s2, 2p6. That's 10. 3s2, 3p6. I'm sorry, 3p6. 4s2, 3d4. Okay, 3d4. So if you look at the periodic table, 3d4 is actually 1, 2, 3, 4. Is actually chromium, right? So it's the same configuration as chromium, but it just means that it's iron, but it has the same number of electrons. So this means is the same as chromium, but it's not chromium. It's just an iron with 2 less electrons. So it's just still the electron configurations for iron, but it's iron plus 2, iron 2 plus. So the ions will change the number of electrons. So it might match another element, neutral element, because earlier we did all neutral element, meaning they are all 0. Okay. So go ahead and finish this part right here. Pause the video, finish this section, and then I'll come down, finish the next 5 questions on your own here, and then I'll show you how to do 7 and 8 here. So number 7 here, 1s2, 2s2, 2p6. So we add up all the electrons. 2, 6, 10, 12, 18, 20, 30, 34, 34. Somehow whoever made this likes 34, which is, well, it's not, the natural one is, it shouldn't be an ion. The first element itself is chromium, right? Just chromium, no charge. So that's not really a chromium. So earlier, if we pick, let's say if we add 2 more electrons, that'll be 36. So if we add 2 more electrons, it'll be Fe. Oh, chromium is 34 electrons. Oh no, 34. It's not 34. Chromium is 24. 34 is Se. My bad. 34 is Se. So, did I add right? 20, 10, 20, 30, 34. 4p4. Let's confirm. 4p4. 4p, 1, 2, 3, 4. Yeah, selenium. Selenium, not chromium. So, my bad. Make a mistake there. So, I made a mistake there. So, Se. So, selenium, right? So, if I want to add 2 more electrons to be krypton, I would, if I add 1 more, so Br, if it's bromine, I need to take away 1 electron, right? Second ion. Bromine has 35 electrons. If I take away 1 electron, it'll be bromine. Bromine plus 1 will be the same thing, because I have to remove 1. Or if I want to pick arsenic, As, if I add an electron, As is 33. If I add 1 more, that'll be 34. So this part is kind of confusing there. But let's see. You know what? Let's just forget about this part. When we do the top part, it should be good. Just forget about this part. But that's just how it works. Okay. Just figure out the number of electrons and what it is. I don't know. I don't like this part. Okay. Just forget this part. I'm not going to do that. As long as you can do this 1 through 6 up here, you are totally fine. Alright. Good job, ladies and gentlemen. Bye-bye.